Good afternoon. All right, looks like everybody's there. I think that is that Gangsta Jada and Hopi. Okay, there you go. Just teasing. All right, hope you guys are all having a good day. Let's see. I do have. Let's see. I think we just have 11:07 is our last section. And then we want to figure out what we're going to do Monday. But today is our last, I think today's going to be our last day of new material. So I'm kind of excited about that. I hope you are too. Let's see. So I did want to tell you that we've got basically 1 week. So 1 week from today at midnight is where all your work is over. And so this last week, you need to really give me your best and work hard. This isn't the time to say, well, let's just see what my grade is or whatever. I mean, this is like a college class, and during finals week in college, boy, you really have to hunker down and really get to it. So I did want to share with you this little picture here, courtesy of Dr. Strange, where he says, we're in the end game now. Okay, so this is the end game for our course here. So this is the time to really step up. So anyway, so I did want to share that with you. All right, well, let's so we're in this last section here, conics in polar coordinates. Okay, so any of you have any questions or comments before we get started here today on 11:7? All right. Okay. Now, I hope that you've kind of felt like that this last chapter has been have been one of the easier ones. I hope you have felt that way. Once again, most of this section is actually in trig, the idea of conics and polar coordinates. We teach this in chapter 9 in the trigonometry book. So hopefully some of that will come back to you. All right. So first of all, we introduce or reintroduce the idea of eccentricity. And the way that we define eccentricity is it's the distance between the foci divided by the distance between the vertices. And so that would be 2c divided by 2a. You divide the 2's, and so this is the formula to find eccentricity. It's c divided by a. Now, what's different about the different conic sections that we've talked about is that there's different ways to find c, depending on what the conic is. Okay, so in the ellipse, to find the c, so it's still is c divided by 8. Well, to get the c, it's the square root of a squared minus b squared. That's how you get the c. In the hyperbola, to get the c, it's the square root of a squared plus b squared. And then for the parabola, C and A are always the same. And so E is always equal to 1 for the parabola. And then you might even add a line here. I left this one off the notes I discovered this morning, is that for a circle, the eccentricity is 0. All right, now, there's another way that you can think of that all of these conic sections have in common is the directrix. Now, typically, we're used to we use the directrix when it comes to the parabola the most. And so when we talked about the ellipse or the hyperbola, I didn't even talk about the directrix because there's actually 2 of them. Okay? And so, but we can find, usually when we find one foci, then we can find the directrix closest to it, is kind of how we do that. Now, the equation of the directrix, if we don't know what the d is, then we can calculate it by a divided by e. And sometimes it's positive, sometimes it's negative. Now, in this case, it's plus or minus. And so, unless you're talking about one directrix goes with one focus and the other goes with the other. And so then you can get the plus or minus that way. But typically, we just find the equation of one directrix given one focus for these. Okay. All right. Now, all right, so another way that we can think of this is, so it says that suppose that P is a point on the conic. So if PF is the distance from the point to the focus, PD is the different distance from the point to the directrix. Okay? Now, so I'm going to kind of put the little bar over it to make you think of this as like a line segment. So it's actually a distance, though. So maybe we shouldn't do that. I guess this is the distance. So the distance from the point to the focus is E times the distance from the point to the directrix. And then the path traced by P is E equals C divided by A. Okay, so E equals C divided by A. So it's the same formula you did before. Okay, now, based on what our E is, we can determine what type of conic section it is. Okay, and so here, so it's a parabola. The conic is a parabola if E is 1. So if E is 1, then that means, which means that C is equal to A for a parabola. Because if a number divided by itself is 1. All right, it's an ellipse if E is between 0 and 1. It's a hyperbola if E is greater than 1. And it's a circle if E is equal to 0. So once we calculate, so in polar form, we can identify fairly easily what E is. And then, so based on that, we can determine what the graph would be, what the conic section would be, without having to put it in in Cartesian form. We can just leave it in polar form and say, oh, look, that's an ellipse. Okay? All right, so this is find a Cartesian equation for the hyperbola centered at the origin that has a focus of 3, 0, and the line x equals 1 as the corresponding directrix. Okay, so first of all, let's kind of break this down piece by piece as to what information this is actually telling us. Okay, so find a Cartesian equation for the hyperbola. So we've got it. So that Cartesian equation means in x and y. So the standard form of the hyperbola centered at the origin is this: x squared over something minus y squared over something equals 0. Now, so if it's centered at the origin and it has a focus of 3, 0, then you actually know it opens left and right and the x squared comes first. All right? Then, so C is defined as the distance between the center and the focus. Okay, so here's the center, here's the focus. So if the focus is 3, 0, that distance is 3. And so we get C is 3. Okay. Now, so C is 3. We also know that the directrix is 1 because we're told that. X equals 1 is the corresponding directrix. And the directrix is A divided by E. So if the directrix is x equals 1, so if 1 is equal to A divided by E, then what does that tell us? If A divided by E equals 1, then what does that mean?
A equals E.
A equals E. For this problem. Now, that's not for every problem. So just for this problem, because this problem says x equals 1. Okay? So then if that equals 1, then A and E are equal to each other. And so then I can substitute. So if E is equal to C divided by A, and A and E are equal to each other, then I get E is equal to C divided by E. So E squared is equal to C. C is 3. So E squared is 3. So E is equal to the square root of 3. And A is equal to the square root of 3. Okay, now I know all that's some tricky substitutions and kind of seeing how things go. But then if A is the square root of 3, then the number under here is A squared. And so it's just going to be 3. All right, then once you have A and C, then you can use this formula here to get B. So you say A squared is 3, C squared is 9, so A squared 3 plus B squared is 9, so B squared is 6. So that means 6 goes under there. Okay, so how did we get this? Well, we had to know the general form of the hyperbola. We had to be given the directrix, and then we had to be given the focus, which is C. And then we used the directrix to find A and E, and then we used this equation for the hyperbola to find B. Now, in the practice problem, its number one difference is that it's it's an ellipse. So the equation is slightly different in that it's a plus in here when you have an ellipse. All right. Now, also when you have an ellipse, this formula here is different because remember when we have an ellipse, then it's a squared minus b squared is equal to c squared with an ellipse. Okay. So those two signs kind of change with an ellipse. Okay. All right. So see if you can kind of put it together and do practice 1. All right, so Weston, what do you have? What are you stuck with? What do you need help with?
1 second. I think I'm almost got it.
Okay.
Okay. So I got x squared over 12.8 plus y squared over 12.16.
Okay, so let's see. X squared over, I got 40 squared.
I had it right the first time, except they
And then
thought it
y
was wrong.
squared over 1,536.
I had it right the first time, and I thought
Did
they
ya?
were too big, and so I went back.
Okay.
Ah.
All right. So let's see why it would have to be that way. Okay. All right. So you get C is 8 because the center is at 0, 0, and the foci are at plus or minus 8. So that distance from the center to the focus is 8. So C is 8, and then they tell you have an eccentricity of 0.2. So that's E. Okay. So then if E is equal to C divided by A, you use that to figure out what A is. So you get 0.2 equals 8 divided by A. So you multiply each side by A and then divide by 0.2, and so you get A is 40. So then underneath here is A squared. And you're right, most of them we did weren't that big, but and then once you have A, then you use C squared equals A squared minus B squared. So C is 8. So we say 8 squared equals 40 squared minus B squared. So that's going to give you 1,600 minus 64, or 1,536 is B squared. And so you could do it here. Now, if you wanted to go ahead and square that out, then you could say x squared over 1,600 plus y squared over 1,536 equals 1. Okay. All right. So, Tobias, how'd you do?
I got lost in the
All
middle.
right. Do you understand what I did up
Yeah.
here, or do we
Yeah,
need to
now
go
I
through?
understand. I got it
Okay.
now.
All right, Jada, how about you?
I did the same thing. Once I saw the 40, I thought it was too big.
Too big. Okay.
Thought I got stuck.
All right. Well, I'm glad I did this problem, because there are times when you're working the problems, you get weird answers like that. So, okay. It does help when it's multiple choice and you see, oh, that is one of the choices. Okay. All right. All right. So next, let's talk about the eccentricity again, but this time we're gonna be in have our polar equations. Now, this blue equation is how your book does it. I actually prefer how the trig book does it, where it's E times D over 1 plus or minus E cosine theta or sine theta. And so this is the formula I like to use. And x equals whatever. So instead of k, I use d. So if you have a cosine in the equation, then you end up with a vertical directrix, and it's x equals plus or minus d. If you have a sine theta, that gives you a horizontal directrix, and it's y equals plus or minus d. Okay, so let's kind of piece this together. Okay, so the first thing is that we want to have our equation in standard form. So with standard form, this 1 here, it needs to be a 1. Okay, if it's anything else, we're going to divide, and so we'll talk about that in just a minute. Okay, so then the next thing that I like to do is to figure out what d is. Okay, now the numerator here is 5 times e, and so in the formula, here let's write down the, let's see here. Okay. Okay, so in the general formula, we have R equals, and then E times D. And so I always say ed is in the numerator, and then we have 1 plus or minus, and then it's sine or cosine. Let's just say cosine theta. Okay, so E times D is in the numerator. So if ed is equal to this numerator, 5e, well, if we just cancel e, then we get d is equal to 5. Okay. All right. So now we can figure out the directrix. Now, there's actually 3 pieces of information that we look at. There's not really calculations here per se, but that we look at to get the directrix, the equation of the directrix. Okay, so the first thing we look at is the trig function. So if it's cosine, then that means it's a vertical directrix, and so it's x equals. The second thing we look at is it plus or minus in here? If it's plus, then then our directrix is going to be x equals plus, and then the d is 5. So that's the third thing. And so we have a vertical directrix because of the cosine, and so the equation is x equals positive 5. So again, the 3 pieces of information to get the directrix. We look at sine or cosine to get x equals. Then plus or minus to get the sign here, and then we calculate d, and then that's the third part. So x equals 5 is the directrix. Okay? The next thing we do is we can calculate e. Well, e is going to be when we're in standard form, the coefficient of the trig function is e. Okay? So let's so it's the coefficient of the trig function. Okay? So in this case, there's just an invisible 1 there. This is 1 cosine theta, so E is going to be 1. All right, now the next thing we do is based on that, look at what we had on the front, in the bottom of the front column on the front page, and say if we have an E of 1, then what kind of conic section is it?
Parabola.
It is a parabola. And so we get that based on what E is. Okay? All right, so okay, so what I would like you to do now is so practice 2. If you look and you see where it says 4E, well, here, I'll just, okay. I'm going to change the problem slightly. Okay, so what I'm going to do is I want you to change this 2 here to a 1. Okay? And then I want you to figure everything else out. All right, so Weston, what is D equal to?
4.
4. Okay, everybody good with that? Okay. All right. What is Toby? What's the equation of the directrix?
Is that x equals 4?
X equals 4. All right. And then Jada, what kind of conic section is this? Oh, no. First, Jada, what is E?
E is 1.
So E is 1. All right. And now, Jada, tell me what kind of conic section is that?
A parabola.
So it's also a parabola. All right. So everybody okay with that? Any questions? Let's see this. So this is a parabola. Okay. So now, so I want you to, we're going to skip to part 4. Next. So part 4 says sometimes in order to get a denominator of 1 plus or minus something, then you have to divide. So what we mean by that is here, it says find E, the type of conic and the directrix for 25 divided by 10 plus 10 cosine theta. All right, so in order to have this in standard form, I need a 1 here. So to get a 1, I'm going to divide everything by 10. Okay? Okay, so I'm going to divide everything by 10. Okay, so now I'm going to get, all right, so R equals, so 25 divided by 10, that's 5 halves. 10 divided by 10 is 1, which is what I needed, plus cosine theta. Okay, so in this case then, once again, I get E is equal to 1 because this is the standard form, okay? So this is the standard form. So E is equal to 1 because that's the coefficient of the cosine. And so then that means once again I have a parabola. All right, now to find D, I say E times D is equal to the numerator 5/2. And so I already know E is 1, so that just gives me D is equal to 5/2. So then the equation of the directrix, so again I have cosine, so it's going to be x equals, and then positive 5/2 is the equation of the directrix. So you do the same thing, but you have to get a 1 there first by division. All right, so go ahead and try practice 4. All right, so Toby, what is the equation in standard form?
2 over 1 plus 1/4 cosine theta.
So 2 over 1 plus 1/4 cosine theta. All right. So Jada, what is E?
Okay, so I wasn't sure if you're supposed to add both of them, the 1 and 1/4, or just the one.
It's just the 1/4. It's just whatever's in the coefficient of the trig function.
Yeah,
So
okay,
it's
fine.
just
I just
it's
did
just
1/4.
1/4.
Yeah.
Okay. All right. So Weston, what type of conic is this?
An ellipse.
Okay. It is an ellipse because it's between 0 and 1. All right. Toby, what is D?
I got D to be 8.
Okay, so D is 8. So then, Jada, what is the equation of the directrix?
X equals 8.
X equals 8. Okay, good. All right, any questions on that? All right, good. All right, so then the last part here is actually building the equation with the directrix. So if the polar equation contains a sine, then the directrix is horizontal and you have y equals. If the polar equation contains a cosine, then the directrix is vertical and its equation is x equals. All right, so here this says find the polar equation for the hyperbola with e equals 3/2 and a directrix of x equals 2. Okay, so you start off and you say, okay, so we're using the general form here, and we're going to plug in d equals 2 from the directrix equation, and e equals 3/2. So we get r is equal to 3/2 times 2 over 1 plus, and then the e again is 3/2 cosine theta. So now I simplify, cancel the 2's on top, and I get 3 over 1 plus 3/2 cosine theta. Now, the deal though is when we're writing these equations, the polar equation, you don't want to have a complex fraction here. So now it's kind of like doing the opposite thing, where now to get rid of this 2, we multiply everything by 2. And so then we're going to get 6 over 2 plus 3 cosine theta. And so that is our polar equation, because we don't want to have a complex number. Okay? All right, so see if you can do practice 3. All right, so Toby, what do you have?
2 over 2 plus sine theta.
So 2 over 2 plus sine theta, is that what you said? Okay. And so that would make it an ellipse. Sorry. It's an ellipse because the e is 1/2. I mean, it didn't ask for that, but anyway, 2 over 2 plus sine theta. R equals that. So any questions on that? All right, well, so Toby, you have the honor of answering the last question on the new material for the whole year, and you got it right. So way to go. Way to go. So, okay, so here's, so we finished chapter 11. That's 11:7. So I'll be open, I've actually opened that up as well as chapter 11. So now what we need to discuss quickly is Monday. All right, so we can either do a final exam review. That's kind of what I plan on doing. But I had a student that approached me in one of my other classes and said, you know, I think we could really benefit from having a Moodle day. And I can see that, especially, you know, where you could take that last quiz or last test and so on before the final. That's a good idea. So what do you guys want to do? Do you want to get together and pepper me with questions on Monday, or do you want to just have it be a Moodle day? So, Jada, what's your opinion? What's your vote?
I kind of want to have a Moodle day.
Okay. All right. Toby, what about you?
I'm honestly good with either of them. They both sound like a good idea.
Okay. Weston, how about you?
I'm the same way. I'm fine with either.
You're fine with either? Well, so if we've got one Moodle and 2 neutrals, I guess that means Moodle wins, right? Okay. So here's the deal then. So Monday we won't have class, but, and this is very important, is that I will be available really all during the week. Even after you've started the final, if you have a question on something, don't hesitate to ask. Also, I just want to show you, just really quickly here. Let's see, going back. So this is on the. Okay, so on the area of the final. So there's if you need more information about the extra credit, don't forget to do that. And then the final exam won't be hidden next week. I'm going to unlock that each part: Tuesday, part 1, Wednesday, part 2, Thursday, part 3. But if you just look at this final exam practice test, this is actually a test that I had given in the past, like, probably 5 or 6 years ago. And so if you just want to look at some of the question types that you could look at again. And then I have selected problems done that students have asked me to work. So going back to the middle under this, these are some of the problems worked out. And so, you can look through, and there's quite a few of them that are worked out for you. If there's any of them that aren't worked out that you want to ask me about, or you don't remember how to do, feel free to do that. Okay. So I'm going to be checking my email a lot this coming week. Okay. And please don't forget the extra credit. And so if any of you, are any of you thinking you might take Calc 3 over the summer?
I will be.
You will be? Okay. So probably I'm gonna just tell you up front, I'm probably gonna miss the first day of class. We probably won't have class the first day because I'm flying to South Carolina for my dad's 80th birthday party. We're doing a surprise party. So probably the first Wednesday of June will be the first day of class. But, we'll say more about that. But really and truly, still, it's not too late if like Tobias, I was kind of hoping that you would tell me that you'd finish those 3 quizzes or whatever, and you want more to retake, or the second attempt or whatever. Okay, we can still do that. Okay, up until next Thursday midnight, and then it's all over. Okay, after that I won't do anything but calculate your grade. But if you need anything, don't hesitate to email me or whatever. Okay, and if I don't respond within 48 hours, then text me or whatever. But I will be responding. I just want to make sure that you have the right deal. So anyway, you guys have been great. I've loved this class, and I wish you guys well. Wes, and I'll see you soon. The other 2 of you, wish you well in wherever college you go to. So good luck. Keep up the good work. All right. So we'll see you. So no class on Monday.
No class Monday.
Thanks, Mr. Strong.
You bet.